Swayam Prabha. Digital India. Educated India.
Welcome to lecture 36 on time series modeling and forecasting. In the last lecture, we discussed the idea of causality for multivariate time series. In particular, we considered Granger's causality, and then we discussed various forms of Granger's causality, say instantaneous causality or feedback or one directional causality or both directional causality, etc. In this lecture, we are going to consider various causality tests. First, we will consider different causality tests for bivariate time series models. Then we will also discuss when you have more than two time series, and we consider the causality test for more than two time series processes. Now, we consider causal analysis using bivariate VAR and bivariate MA representations. The AR representation of the process is defined as AL YT XT equal to alpha 11 L, alpha 12 L, alpha 21 L, alpha 22 L YT XT, which is equal to UT VT. Here AL is a matrix polynomial, its order is 2 cross 2. Then alpha JKL is equal to summation I equal to 0 to infinity alpha JKI L to the power I. J and k take values 1 and 2. Then alpha j k I is the coefficient of L to the power I in alpha j k L. To normalize the system, we take alpha 11 naught equal to alpha 22 naught equal to 1. Then alpha j k L is equivalent to 0 if all their coefficients alpha j k I are 0. UT and VT are white noise which might be correlated with each other. Now, XT does not Granger cause YT if alpha 1 2 L is equal to 0 or the corresponding coefficients alpha 2 1 to I equal to 0 for all I equal to 1 to so on. Then instantaneous causality exists if and only if the current value of U, say UT, is correlated with the current value of VT. So, if UT and VT are correlated, then the instantaneous causality exists, because in that case the forecast error of y is reduced if the current value of x is included in the forecast regression. Either alpha 1 2 naught is not equal to 0 or alpha 2 1 naught is not equal to 0. So, either x is instantly causing y or y is instantly causing x. Now, we consider the MA representation of the process, which is YT XT equal to BL UT VT, and then we write it as beta 11 L, beta 12 L, beta 21 L and beta 22 L UT VT. BL is the matrix polynomial with elements beta JKL. JK equal to 1 2. And then beta JKL is equal to summation I equal to 0 to infinity beta j k I L to the power I, and we take beta 1 1 naught and beta 2 2 naught equal to 1. Then for the identifiability of the model, we also take beta 1 2 naught or beta 2 1 naught equal to 0. Otherwise, what happens? Both the models look alike. So, you will not be able to distinguish between two. So, we take beta 1 naught and beta 2 1 naught equal to 0. Then x t does not Granger cause y t if beta 1 to L is equal to 0, or beta 1 to I is equal to 0 for all I. Now, beta 1 1 L, beta 1 2 L, beta 2 1 L, beta 2 2 L is equal to alpha 1 1 L, alpha 1 2 L, alpha 2 1 L, alpha 2 2 L inverse. And since this is a 2 cross 2 matrix, you can easily find the inverse of this matrix. Determinant value of this matrix is alpha 1 1 L, alpha 2 2 L minus alpha 1 2 L, alpha 2 1 L, which is represented as eta L here. And then beta 1 1 L is equal to alpha 2 2 L divided by eta L. Beta 1 2 L is equal to minus alpha 1 2 L divided by eta L. In fact, we take cofactor of this matrix 2 by 2 matrix, and then we divide each element by the determinant of the matrix, that is eta L. Then we find beta 2 2 L is equal to alpha 1 1 L upon eta L, and beta 2 1 L is equal to minus alpha 2 1 L upon eta L. And from here we observe that beta 1 to L is equal to 0 implies that alpha 1 to L is equal to 0, and beta 2 1 L is equal to 0 implies that alpha 2 1 L is equal to 0. Hence, x t does not Granger cause y t if beta 1 to L is equal to 0, or if beta 1 to I is equal to 0 for all I equal to 1 to so on. Then the hypothesis that all cross lax coefficients are 0 means, say suppose you want to test this hypothesis, all beta 1 to I are equal to 0, can be tested using F test for testing significance of the coefficients. Now, we characterize causal relations using residuals of individual univariate processes of x and y. Means so far we have considered the AR representation for characterizing the causal relations, or MA representation for characterizing the causal relation. Now, we consider the residuals of individual univariate processes of x and y for characterizing the causal relation. So, using Wald representation, we can express y t and x t by two separate MA processes of infinite order. So, now y t is a stationary process. So, we can write it as y t equal to psi 1 1 L A t, where psi 1 1 L is equal to, or in general psi j k L is equal to summation I equal to 0 to infinity psi j k I L to the power I, and this A t is a purely random process. Similarly, in the MA representation of x t, we use the polynomial psi 2 to L. and this Bt is a purely random process. Then we can write 3 in the form Yt xt equal to psi L At Bt, where this psi L is equal to psi 1 L is the 1/1th element of psi L, psi 2 L is the 2/2th element, and 1/2th and 2/1th elements are equal to 0. So, psi L is a diagonal matrix. Further, you can write Yt xt equal to psi L inverse Bl Ut Vt. In fact, Yt xt is equal to Bl Ut Vt. So, we have multiplied by psi L, and then we have taken inverse of psi L here. So, you get Yt xt equal to psi L inverse Bl Ut Vt, and this is equal to psi L HL Ut Vt, where HL is equal to psi L inverse Bl. Again, this HL is a 2 by 2 matrix, and we write this HL as eta 1 L, eta 1 2 L, eta 2 1 L, eta 2 2 L. So, you get Yt xt equal to psi L eta 1 L, eta 1 2 L, eta 2 1 L, eta 2 2 L Ut Vt. So, HL is equal to psi L inverse Bl. So, from here you obtain At Bt is equal to psi L inverse Yt xt, or psi L inverse Bl Ut Vt, and psi L inverse Bl is equal to HL Ut Vt. Now, remember that these At and Bt are the residuals for individual representations or individual MA representations of Yt and Xt. Then eta j k L is equal to beta j k L divided by psi j j L. This you get from here. HL is equal to psi L inverse Bl, and this psi L is a diagonal matrix. Its diagonal elements are psi 1 L, psi 2 L. So, this is actually equal to psi 1 L inverse 0 0 psi 2 L inverse, and then you have Bl, which is beta 1 L, beta 1 2 L, beta 2 1 L, and beta 2 2 L. So, from here you obtain eta j k L equal to beta j k L divided by psi j j L for j k equal to 1 2. So, for instance, for j and k both equal to 1, you have eta 1 L equal to beta 1 L, this divided by psi 1 L. Then alpha 1 2 L is equal to 0 implies that beta 1 2 L equal to 0, and this further implies that eta 1 2 L is equal to 0. So, x t does not Granger cause y t if eta 1 to L is equal to 0 or eta 1 to I, the corresponding coefficients are equal to 0 for all I. Then the cross covariance between A t and B t is gamma A B k is equal to expectation of A t B t minus k. Now, this is equal to expectation. You write A t equal to eta 1 1 L u t plus eta 1 2 L v t into B t minus k is eta 2 1 L u t minus k plus eta 2 2 L v t minus k. So, we write the values of A t and B t minus k here, and this is equal to eta 1 1 L u t into eta 2 1 L u t minus k plus expectation of eta 2 1 L u t minus k eta 1 2 L v t plus expectation of eta 1 1 L u t eta 2 2 L v t minus k plus expectation of eta 1 2 L v t into eta 2 2 L v t minus k. Then assuming no instantaneous causality, u t and v t dash are uncorrelated for all t and t dash. So, these are purely random processes, and in case of instantaneous causality, u t and v t will be correlated, and if there is no instantaneous causality, then u t and v t dash are uncorrelated for all t and t dash. Even for t equal to t dash, u t and v t are uncorrelated. So, we obtain gamma A B k equal to expectation of eta 1 1 u t eta 2 1 L u t minus k plus we remove this term because this involves both u t and v t. We also ignore this term, this has expectation 0 because it involves both u t and v t. Then you have the last term expectation of eta 1 to L v t plus eta into eta 2 to L v t minus k. Now, when x does not Granger cause y, then you have eta 1 to L equal to 0, and in that case A t is equal to eta 1 1 L u t. Both u t and A t are white noise processes, and then both the representations of y t, one with u t and another with A t are y t equal to beta 1 1 L u t and y t equal to psi 1 1 L A t. So, you have these two representations of y t, and in both the representations u t and A t are white noise processes. So, this implies that eta 1 1 L is equal to 1. Remember that y t is a stationary process. So, it has a unique infinite order M A or infinite order autoregressive representation. So, from here you obtain eta 1 1 L equal to 1, and remember eta j k L is equal to beta j k L divided by psi j j L. Further, this implies that A t is equal to u t. Then gamma A B k is equal to expectation of u t eta 2 1 L u t minus k, and this is equal to 0. Because this second term does not involve u t, and u t is a purely random process. So, u t is uncorrelated with eta 2 1 L u t minus k. and this expectation is equal to 0 then. So, the cross correlation rho A B k is equal to 0 for all k. Similarly, when y does not cause x, rho A B k is equal to 0 for all k, and this is for instantaneous causality. So, if x does not instantaneous cause y or y does not instantaneous cause x, then rho A B k is equal to 0 for all k. Or you can say when x and y are independent, rho A B k is equal to 0 for all k. Now, this result actually forms the basis for half Pierce causality test, which we will discuss later on. Now, we consider different causality tests. The first one is the direct Granger procedure, and this procedure was proposed by Thomas Sargent in 1976. Now, suppose x t and y t are two stationary time series, then test for simple causality from x to y is equivalent to examining whether the lagged values of x in the regression of y on lagged values of x and y significantly reduce the error variance or not. So, if we consider the models m1 y t equal to alpha naught summation k equal to 1 to k 1 alpha 1 1 k y t minus k plus u t, and m2 is the model y t equal to alpha naught plus summation k equal to 1 to k 1 alpha 1 1 k y t minus k plus summation k equal to k naught to k 2 alpha 1 to k x t minus k plus u t. You have these two models. So, this model 1 does not involve the lagged values of x, whereas the second model involves the lagged values of x. Both the models involve the lagged values of y, but the first model does, these are the lagged values of y. So, both the models involve lagged values of y, but the first model does not involve lagged values of x, whereas the second model involves lagged values of x. So, according to the first model, x does not Granger cause y, and according to the second model, x Granger cause y. So, for testing whether x Granger causes y or not, you have to test the hypothesis whether these coefficients alpha 1 to k for all values of k are significant or not. Then before that, we estimate both the models using least squares with k naught equal to 1. Usually, we take k naught equal to 1. Then the Granger causality index is defined as g c I equal to log of sigma head square u 1 divided by sigma head square u 2, where the sigma head square u 1 is the estimated error variance for the model 1, and sigma head square u 2 is the estimated error variance for the model 2. So, basically you want to test the null hypothesis H naught alpha 1 to 1 is equal to alpha 1 to 2 equal to so on equal to alpha 1 to k equal to 0. and testing this hypothesis is equivalent to testing H naught, the true model is M 1, against H 1, the true model is M 2. True model M 1 means X does not Granger cause Y, and true model M 2 means X Granger cause Y. Again, we have taken K naught equal to 1. So, we have overruled the possibility that there is instantaneous causality. Now, suppose RSS1 is the residual sum of squares for the fitted model M1, RSS2 is the residual sum of squares for the fitted model M2. Then for testing the significance of difference between these variances, you can use the Fisher F statistic, which is F equal to RSS1 minus RSS2 divided by K2, this divided by RSS2 divided by n minus K1 minus K2 minus 1. And under the null hypothesis that X does not Granger cause Y, this statistic follows F distribution with K2 n minus K1 minus K2 minus 1 degrees of freedoms. So, the test statistic for obtaining this test statistic, you simply have to run least square regression for model 1, least square regression for model 2. Then we obtain the residual sum of squares for the fitted model M1 and residual sum of squares for the fitted model M2. And then you can compute this F statistic. And since under H naught, this statistic follows F distribution with K2 n minus K1 minus K2 minus 1 degrees of freedoms, you can easily form the critical region for testing H naught. If this calculated value is greater than the tabulated value, say at 100 alpha percent level of significance, then we reject H naught, otherwise we accept H naught. And that critical value or tabulated value you get from the F table. Then interchanging X and Y in M1 and M2, a simple causal relation from Y to X can be tested. Say we have tested whether X Granger causes Y or not, and in the same setup, if you interchange the roles of X and Y, you replace X by Y and Y by X, then you can test the hypothesis whether Y Granger causes X or not. Again, you have to use the F test. Now, if the null hypothesis is rejected in both the directions, we conclude that there is a feedback relation. If the null hypothesis is accepted in both the directions, then you say that neither X Granger causes Y nor Y Granger causes X. But if null hypothesis is rejected in both the directions, then we say that there is a feedback relationship between X and Y, that is X Granger causes Y and Y Granger causes X. Then for testing instantaneous causality, you set K naught equal to 0 in M2, and then you test the hypothesis H naught alpha 1 to naught is equal to 0 using t test. So, this is simple. Suppose you want to test the instantaneous causality, then you take k naught equal to 0 in the second model, and k naught equal to 0 means you have involved a term containing x t, the current value of x in the model M2, and under H naught is the hypothesis that there is no instantaneous causality, or alpha 1 to naught is equal to 0. You can apply the usual t test, means t test for testing the significance of a single regression coefficient. Now, there are some shortcomings of this test. The results are strongly dependent on the number of lags of the explanatory variable k 2. Say under the model M 2 or the model under the alternative hypothesis, we have included number of lags for the explanatory variable up to k 2. And the results of the test strongly depend upon the value of k 2. Then there is a trade off. The more lagged values we include, the better the influence of this variable can be captured. So, if you increase the value of k 2, it means you are capturing more the effect of more lagged values of the variable x, but the power of the test decreases as more lagged values are included. But if you include less lagged values, then it may happen that the values which you have ignored have influence on y. So, that influence will not be captured. So, there is a trade off between these two. Then the option is use different values of k 2 and of course, of k 1 also. Usually, we start with k 1 equal to 1, but you may select different value of k 1 also. So, we use different values of k 2 and k 1 to inspect the sensitivity of the results to the number of lagged variables. And then you use different information criterion also, say Akai K information criterion or Bayesian information criterion to select k 2 and k 1. So, you try different values of k 2 or k 1, and then you select a model using some information criterion like AIC or BIC. So, this is one option. Now, we come to half Pierce test. In this test, what we do? We fit univariate ARMA models for x t and y t, and then we obtain the estimated residuals. Say B t head is the estimated residual for x t and A t head is the estimated residual for y t. Then we obtain the cross correlations between B t head and A t head, say rho head A B k. For different values of k, we obtain the cross correlations between these two residual series, B t head and A t head. Remember that we have already shown that if you have ARMA representation for x t, individual series x t and individual series y t, and if there is no causality, then the corresponding residuals are uncorrelated. And this test uses the same logic. Say we fit ARMA models for individual series, we compute the estimated residual series, say BT head and AT head, and then we obtain the cross correlations between these two estimated residual series, say rho head ABK. Then we use box pairs Q statistic or box Young Q statistic to test the null hypothesis that the estimated residuals are white noise. And if hypotheses are not accepted, then we calculate the following statistic: S equal to n summation k equal to k1 to k2 rho head square ABK. You may take k1 equal to 1. So, you may start with k1 equal to 1. But before that, you must test the null hypothesis that the estimated residuals are white noise. Otherwise, you have to modify the ARMA process which you have fitted to xt and yt. Then under the null hypothesis H naught, rho ABK is equal to 0 for all k, and we are going up to lag k2 say. And so, this k lies between k1 and k2, and under this null hypothesis, this statistic S is asymptotically distributed as chi square with k2 minus k1 minus 1 degrees of freedoms. Now, you can form a critical region. Say suppose you want to test this hypothesis H naught, rho ABK is equal to 0 for all k, k lying between k1 and k2. Then you calculate this statistic, and if you are using say 100 alpha percent level of significance, then from chi square table you obtain the tabulated value at k2 minus k1 minus 1 degrees of freedoms. You compare the two values. If calculated value is less than the tabulated value, then we accept null hypothesis, otherwise we reject the null hypothesis. And accepting the null hypothesis means there is no causality, or rejection of null hypothesis means there is causality, either x causes y or y causes x. Now, whether there is any causal relation, check for k1 less than 0 and k2 greater than 0. And if this hypothesis can be rejected, causal relation from x to y can be checked if k1 is equal to 1 and k2 greater than or equal to 1. So, first we also check this hypothesis for k1 less than 0 and k2 greater than 0. And if we reject this hypothesis, then we start from k1 equal to 1 and k2 greater than or equal to 1. In the reverse direction, for k1 less than or equal to minus 1 and k2 equal to minus 1, it can be checked whether there is a simple causal relation from y to x. So, you can also check if there is any simple causal relation from y to x, and for that purpose you have to take k1 less than or equal to minus 1 and k2 equal to minus 1. So, you are moving in the reverse direction, and it can be tested for using rho a b 0 whether there exists any instantaneous relationship. Now, suppose we have m time series j t j equal to 1 to m. Then we extend the estimating equation so that we include all these m time series also. So, our estimating equation is now y t equal to alpha naught plus k equal to 1 to k 1 alpha 1 1 k y t minus k plus summation k equal to 1 to k 2 alpha 1 to k x t minus k. Then we have another term j summation j equal to 1 to n k equal to 1 to say k j plus 2 beta j k z j t minus k plus u t. So, all these m times these are included in this term. So, we have incorporated all these m time series in the estimating equation. Beta j k is the coefficients corresponding to additional variables. Then after first we determine the values of k 1, k 2, k 3, so on k n plus 1. Then after determining these values, we estimate the model using least squares. Then using F test, we can test hypotheses such as whether different coefficients of x variables are significantly different from 0 or not. Then we can also test if there exists a simple causal relation from x to y or feedback. Then the significance of coefficients of other time series say z j's can also be tested by using the F test. So, the advantage with Granger's test is that it can be extended for more than 2 time series also. Then for systems with more than 2 variables, are the inferences drawn from bivariate tests misleading if you have more than 2 variables? Say instantaneous relations detected with the direct Granger procedure or half Pierce test using bivariate tests are only preliminary. Definite evidence about whether these relations are real or spurious can be drawn in a complete model using additional information. So, if you have some additional time series also, so unless you include that additional information in your model, your inferences may be misleading as per instantaneous relations are concerned or instantaneous causality is concerned. Then if third variables are ignored, conclusion regarding feedback relation might be spurious. So, here also you get some wrong inferences if you ignore the other variables which are relevant. Then inclusion of other relevant variables might reduce it to a one-sided relation. Suppose you have a feedback relation, and if you include other relevant variables, then the inference drawn on the basis of your wrong model, the model which has not included many relevant variables, and your inference was there is a feedback, then that feedback relation might be reduced to a one-sided relation. If the relation between x and y is only one-sided in the bivariate model, there are no third variables which are Granger causal to x and y. So, in this case, if the relation between x and y is only one-sided in the bivariate case, then there are no third variables which are Granger causal to x and y. So, in this lecture we have discussed how you can represent causal relationships or causality for the autoregressive and moving average representations of the process. We have also considered different causality tests, so direct Granger procedure or half Pierce test. We observe that in direct Granger's procedure, you require lag length of x t's, and if you incorporate more than desirable terms of lag, then the test will be less powerful. On the other hand, if you reduce the lag length and some of the relevant lag values of x are excluded, then again it may lead to wrong conclusion, because you are losing some relevant information. Then half Pierce procedure does not require such kind of lag length. For half Pierce procedure, you just fit different RMA processes for the 2 time series, then you obtain estimated residuals. Then the procedure is based on testing the significance of cross correlations for the 2 series. We also discussed how to select lag length in direct Granger's procedure, and then we consider the case when you have more than 2 time series. Of course, half Pierce procedure cannot be extended for the case when you have more than 2 time series, but you can extend the Granger's direct procedure to include this case, means the case when you have some other time series also apart from x t and y t. And we also observe that if you discard some of the relevant time series, then it may lead to wrong conclusion regarding the causality. Say for example, it may lead to feedback relation when there is no feedback relation. So, the test based on 2 time series x t and y t leads to the conclusion that the 2 time series have feedback. But actually, if you include some other relevant time series, then you get the conclusion that there is one directional causality only. Similarly, for the instantaneous causality also, if you are excluding some of the relevant time series from your estimating equation, then it may lead to wrong conclusion. So, it is very important to formulate your model or to identify your relevant variables to be included in the estimating equation. Otherwise, your test procedure will not lead to proper conclusions. So, I am going to stop here. Thank you.
Hi, I am Chitwan Lalji, a PhD student of Health Economics under the supervision of Dr. Debayan Pakrashi from the Department of Humanities and Social Sciences, IIT Kanpur. In one of my essays, I am interested in understanding the relationship between consumption of fruits and vegetables and various health indicators. Health indicators, both subjective and objective health indicators like mental health, self-assessed health, various measures of blood pressure and various measures of cholesterol. Measures of blood pressure like systolic and diastolic BP, you have your incidence of high BP, MAP and incidence of high MAP. And as far as cholesterol is concerned, I have tried to concentrate more on total cholesterol, good cholesterol and incidence of high cholesterol. Now before I go on to what have been my major contributions and various policy implications, I would like to briefly tell you about the policy initiatives of WHO and various countries. The WHO, that is the World Health Organization, it started with a campaign of 5 a day. That is, you should have 5 portions of fruits and vegetables per day. That would be approximately, you could say, 400 grams of fruits and vegetables. Now a portion, before we go further, I'll just tell you what exactly is a portion. One portion is equivalent to a medium-sized apple, or one small glass of fruit juice, which is approximately 150 milliliters, and maybe 3 teaspoons of vegetables. So the WHO went with the 5 a day campaign, which was further taken up by various countries. Countries like UK, Netherlands, Germany, Norway, they adopted the 5 a day policy, while some went for expansionary dietary policies like France, Australia, Canada, Denmark. So for example, Australia, it went for 2+5 policy, in which it said that you should consume 2 portions of fruits and 5 portions of vegetables per day. And USA went for a policy of fruits and vegetables more matters. That is, you must consume more and more fruits and vegetables. Now irrespective of these expansionary dietary policies and dietary propagations, it has been found that only 28% of women and 25% of men, they actually meet the recommended dietary norms of 5 a day portion. So the major contribution of my work is firstly to find an association between fruits and vegetables, whether there exists a relationship between fruits and vegetables and health indicators, and if they exist, whether due to heterogeneity in the data, so I will be doing it according to age, by gender and by your weight. So apart from that, I will go for policy recommendations, in which I am basically studying how much fruits and vegetables matter. Apart from that, which type matters more. So for that, I have taken data from the Health Survey of England. Health Survey of England is an annual survey which takes data, which conducts information regularly on demographic and socioeconomic characteristics. You have your lifestyle behaviors, like an individual smokes or doesn't smoke, alcohol consumption, you have your sedentary and physical activities, and you have various health indicators also which have been collected. Before I go on to what exactly is my research, I would like to concentrate more on fruits and vegetables, like what kind of questions were asked in the survey. Questions like, what kind of fresh fruit do you eat? Did you eat any dried fruit yesterday? Don't count dried fruits in cereals, cakes. Apart from that, for vegetables, they asked how many tablespoons of vegetables did you eat yesterday? So approximately after this whole survey was conducted, data was converted into portions of fruits, and like for example, 3 tablespoons of vegetables is equivalent to 1 portion. So data was converted and provided to the users, that is us, from the UK Data Health Survey. So the major contributions of my paper is that I found a strong negative association between intake of fruits and self-assessed health, then various measures of blood pressure like mean arterial pressure, high blood pressure, systolic and diastolic BP, and your total cholesterol. Apart from that, I have found a strong positive association between consumption of vegetables and good cholesterol. So it is recommended in a way that if you want to control your blood pressure, you must consume more and more fruits. And as far as vegetables are concerned, they impact your good cholesterol. Apart from that, I went in for a falsification test. A falsification test is basically conducted to know whether the model that you have adopted and the conclusions that you are drawing are not spurious. So if a falsification test is done to know, in a way it is tested by seeing an indicator, a health indicator, which is not being impacted by your consumption of fruits and vegetables, and then we see whether there is significant result or not. If there is no significant result, that means your model is good and your results are non-spurious. So what we did is, for falsification test, we took ear complaints and infectious diseases. Now ear complaints, like if you are deaf since birth, or you have some kind of imbalance, body imbalance, that is not being impacted by your consumption of fruits and vegetables, and we did find insignificant results. Apart from that, infectious diseases like HIV, AIDS, etc., we found similar insignificant results, indicating that our results are not non-spurious. Apart from that, we went, since there was a lot of heterogeneity in the data, like by gender, by age and by weight, we did the regression analysis. We found results which stated that as far as fruits are concerned, it impacts a male's health more than a female's health. So it is basically said a man should consume more fruits to impact his health, whereas as far as vegetables are concerned, they impact a women's health more. But this has been only seen as far as cholesterol is concerned, the various measures of cholesterol like total cholesterol, good cholesterol and your incidence of getting high cholesterol. Now after this we went in for a policy implication, and in the policy implication we tried to find two policy implications, what matters and exactly how much portion matters. So as far as how much portion matters, we have found that on an average 5 or more portions of fruits impact your overall health, that is your self-assessed health, your MAP, your incidence of high MAP and incidence of high BP. But if you want to have a good mental health, so you can optimize your mental health by consuming 3 or 4 portions of fruits as well. And similarly, as far as self-assessed health and total cholesterol is concerned, an individual must consume 4 to 5 portions to optimally have the impact of consumption of fruits. Apart from that, vegetables have had a very little impact on your health. It only impacts your incidence of getting high MAP and high BP, and it's seen that only it impacts when you consume 5 or more portions of fruits. So an optimum consumption of 5 or more portions of fruits and vegetables are recommended, but fruits have a more impact on your overall health, on various measures like self-assessed health, mental health, your various measures of blood pressure and various cholesterol levels. Another thing that we find is which type of fruit matters. It has been seen that all size fruits, they impact your self-assessed health, your systolic and diastolic blood pressure, your mean arterial pressure, your high BP and incidence of getting high MAP and high cholesterol. But we find that as far as frozen fruits or canned fruits are concerned, they help in regulating your incidence of getting high MAP or high BP, but it has a trade-off. That means there is something negative happening. It reduces the good cholesterol in your body. Apart from this, if you have an incidence of getting high cholesterol, it is recommended that you must consume fruit juices because it has a impact in reducing your probability of getting high cholesterol. And dried fruits, they impact your self-assessed health. As far as vegetables are concerned, very little impact has been seen. It has only been seen in case of portion of salads and its association with self-assessed health. Another thing that they have seen is vegetables in composite, they have an association with good cholesterol. So overall, my research basically says that there is an association between consumption of fruits and vegetables and various health indicators. And it is highly recommended that an individual, in order to be healthy, must consume 5 or more portions of fruits and 5 or more portions of vegetables per day. But fruits have a more impact on your overall health. Apart from that, all size fruits, they have a better impact on your overall health, your mental health, various measures of blood pressure and cholesterol. So, thank you.